Hello everyone. Uh, Today we will learn CYGWIN environment to install mHM latest version 5.11.1 that was released some time ago. After 5.10, the developers decided to use only CMAKE instead of Makefile. So it's a quite big change for the users that were using only make command. I will try to describe step by step here CYGWIN steps that for Windows users it's really inevitable to follow these steps. First of all, we have to install CYGWIN to our computer, and CYGWIN has a setup exe file. Let's find it in my computer. This one x86 for 64-bit. When you run it, you will continue next, and choose one of the mirrors sides. Later on, you will get such a window. In this one, you should select category, and then you should be very careful with the libraries that are required for mHM. Let's quickly look at mHM libraries, CYGWIN libraries that are required. From 5.10, you can find a manual here. Getting started. Receive the mHM from GitLab page. Here, if you search GitLab mHM, it's here. And in the first begin, it stays develop. It's not stable. You should select the one that is released, and then you should download it as zip file. Once this zip file is ready, you should bring it to a place where it is downloaded as a zip file. Later you unzip it, and this is now ready for further steps. But I would like to explain how you download the libraries. In this category view, not pending, but category, please. Step by step, you search netcdf, and in the libraries, you select one by one these CDF libraries. Just in case, I install one by one, but all of the libraries, and the rest, the math debug is not necessary. HDF5, you search in category view, and the libs you download. Later on, GCC, you download. You say from here install. It is already installed because it says keep. And Fortran, you install by selecting one by one. Don't do this one. Don't do the install in the libs row, it will install unnecessary entire libraries that will explode your CYGWIN folder. If you look at this one for now, it is when I make a neat installation, it is just around 2 gigabytes of space. But if you forget and do wrong selections, installing everything by this one, select all, it will download entire libraries from CYGWIN that will blow up your folder. Then CMAKE, this is new. You download this CMAKE and you can select one by one. The space is not that much, just to avoid some risks. This is documentary doc, but you can download other editors as well. Debug is not necessary. And make, automake, and here this make is necessary, especially we have CMake and make, and these are not necessary. Utilities, make password, not necessary. And then you are all set. You can confirm these windows, these libraries from here: netcdf packages, hdf5, gfortran. When you search for Fortran, you will see also gfortran libraries. And then make one more thing, CMake. We got it already. You should download CMake. This is important detail. At least 3.12 is required. Here 3.17. Then this is this is the thing that that should be noted. Do not select or install the library line. Install option at libs line. So try selecting each library, each row itself. And then you go to the mHM, you choose the latest version. For now it is 5.11.1. How do we do that? Here 5.11.1. This is a bug fixed new version. You download from zip, and then you bring the zip to a place where you want to download. Here it's the unzipped folder. You take the path and you open your CYGWIN that you installed, all set up the libraries, and we can stop this. All right, this is CYGWIN environment. We will try to install the steps. Actually, there's an installation step here in the doc. You should look at this install. Here we are updating required steps for CMake, so you should be careful with these steps. As you see, we have a YouTube video that I'm releasing, and then especially this flag is important, and for memory dump option with OpenMP, it's important that you run this this step as well. All right, let's begin. We have selected the path in between the brackets, in between this two commas. You go to change directory to the place, and let's follow from here as well. Let's keep this one here. Okay, we unzipped, and we unzipped it. You make their new folder called build, and then you go to this build folder, and then you will run this line. It is in the website, as I showed you. We just released updated. So you take this one and copy it to your CYGWIN. Okay, let's keep it simple. We are here. You see, let's create a subfolder, make directory build. Build is created. Go to build. Okay, it's now empty. What do we have to do? You copy this line CMAKE, and at the end you need to put 2 points. Be careful. Just CMAKE and 2 points that is indicated in this website will create files for serial run. But if you want OpenMP technology for your runs to use all the threads, all the seeds of your computer, you should use this memory allocation line plus OpenMP string on and release type. All right. Once you do that, it will read the specification of your system, and we are done. This is, we can ignore that one. So you will use 10.2 for now, and then the version is 5.11 March 2021, and OpenMP will be used. All right, we are ready to say make. It will continue until 100%. Later on, we can keep this open. Meanwhile, I would like to show you one detail. Let's see the task manager here, the performance. I would like to show you the difference between OpenMP and serial run. Okay, I will find it folder first. Here I have a serial exe and parallel executable with OpenMP. I can try this one. In another terminal, go to this one, cd exclamation. Yes, we have here two files. Let's use first serial. Let's keep it simple, mHM. This is serial one. The model is running. It's finished. It used only one of the threads. Let's rename this back to serial and use the parallel one. Well, maybe with this test basin, the difference will not be visible. I will focus on another large basin. As I said, it's not that visible, but I will try to show you a real parallel case. from a larger basin. I will find the place first. Let's look at here. It's 52 yet. It will continue until 100%. So we have still time. I want to show you one detail. I will run it via MATLAB because I believe it's really appealing to see how your computer is working all together. This can remain here. For example, if you run it from here, you will see there are 6 basins, and be careful with the processes here, how the computer will be forced to run all the 16 threads. Now it's reading, model is reading data from 6 large European basins. Meanwhile, we see that it's 81, 82. The mHM executable will be created in build subfolder. You should be careful with that. Yes, since this is a large setup, still reading the files. Okay, we will see this one in a couple of minutes. Warming up, reading the files takes time. We were here, and build folder now has a lot of things. Copy CP mHM exe from this level to upper level. Then mHM exe is copied from this folder to this level. Why it is necessary? mHM executable should be accompanied by these 3 NML files, and we can run when they are together. Oh, I should not run it in CD build subfolder. I should go up and then mHM. That was a nice experience. It's running, and look at the difference, guys. This is important. Here, if you compile correctly with OpenMP, it will be saying this one. it's using 16 threads. Okay, what does this 16 threads mean? I have 16 windows here. Yes, now I'm sorry, this is in the D drive. I should look at the other one. Sorry, it in the MATLAB. I should look at. Soon it will fly. Watch it. Watch this. Soon it will be full performance. If you look at the beginning, it will use 16 threads. So running mHM uh, from MATLAB is also possible. That's so simple. Let's see what it will not open up probably, but I can show it. Yes, now it's running. Look at, watch it here. You see, flat wave arrived, occupying all your resources. OpenMP is doing its job. Calculations are much faster. It's like par 4 in MATLAB. Serial run would fill up only one of them, would be much slower, but look at here. Your CPU is fully used, and you see there are quite a lot of cells to be processed for the hydrologic cycle, hydrologic calculations. And now you see this is full power running your model. This will really speed up your model runs and help you to complete your thesis on time. And that was it for today. So I hope you will enjoy new features in the model. That is really a nice model with flexible options, NPR, and special calibration tools that is engaged in the code. Okay, thank you very much for watching. We will continue new videos with Ubuntu TSL and with Linux machines in UHEM.